In this part of the lesson for Taylor polynomials, we're going to look at two specific examples, which are very much like the problems that you'll be doing in your homework assignment. Now, before we go on, I want to just quickly review our general form for Taylor polynomials. So you recall our Taylor polynomial equaled f of a plus f prime of a times x minus a plus f double prime at a times x minus a squared over 2 factorial. Let's shrink that down a bit, plus our general term, which is the nth derivative at a times x minus a to the n all over n factorial. We're going to need to remember that in order to write them. We're also going to have the more specific Maclaurin polynomial, where we're centered at 0, and so that one's going to be f of 0 plus f prime of 0 times x plus f double prime of 0 times x squared, that's over 2 factorial, plus, and then the general term of that, the nth derivative at 0, x to the n all over n factorial. So we're going to be referring to those as we go through these problems. So let's move to our very first problem. So in our first problem, we want to write the second degree Taylor polynomial for y equals cosine x, and this is centered at 0. So the first thing I'm going to do over here is, and I like using f for these, so I'm going to rewrite this as f of x equals cosine x. And I know that this is going to be a second degree Taylor polynomial, which means I'm going to need to go through my derivatives up through the second derivative. So right here, I'm just going to get all my derivatives. So I remember that the derivative of cosine is negative sine x, and then the derivative of negative sine x is going to be negative cosine x. All right, now for my polynomial, I need these values at where the center is, and the center is 0. So now I'm going to evaluate these, f of 0. So f of 0 is the cosine of 0, and the cosine of 0 is 1. F prime of 0 is the negative sine of 0, which is 0, and f double prime at 0 is negative times the cosine of 0, which is 1. Now I have all my building blocks ready to write the second degree Taylor polynomial. So here we go. Second degree Taylor polynomial, the first thing I need is f of 0, which is 1. The next thing I need is f prime of 0, which is 0 times x. And then I need my second derivative at 0, which is negative 1. I put that over 2 factorial times x squared. And then probably I want to clean that up, because usually we would write that simply as 1 minus 1/2 x squared. And we have achieved our second degree Taylor polynomial for cosine x. All right, so we're going to go to the next slide. And now we're going to be working with the same problem, but we want to bring it to a fourth degree Taylor polynomial. The good news is we don't actually have to redo the first few terms, so we can use everything we already had. So I'm going to go back to that previous slide, and let's grab that Taylor polynomial we had. So we're going to copy that. Oops. Copy it here, and we'll come in over here and we'll paste that in here. So we can start off with this and just keep building, and we need to see where we left off, and we can see the second derivative was negative cosine x. So here we go. We knew the second derivative was negative cosine x. We're going to need the third derivative, which is going to bring us back to sine of x, and then the fourth derivative equals cosine x. We'll evaluate those at 0 because this is centered at 0. So the second derivative, oh, we already had that one, so we only need to go down here. Third derivative at 0 equals sine of 0, which is 0. And the fourth derivative at 0 is the cosine of 0, which is 1. So I take that polynomial I have up above, and I take 1 minus 1/2 x squared, and now I'm going to add the third derivative, which was I'll write it in for now. We can see it's all going to go 0, but it'll be 0 over 3 factorial x cubed plus, and then I take the fourth derivative, which was 1 over 4 factorial x to the fourth. And if we clean that up, oops, this is no longer the second, it's our fourth, so p sub 4 equals 1 minus 1/2 x squared plus 1 over, and we can leave it as 4 factorial, or we can say, well, I know 4 factorial is 24x to the fourth. And you'll recognize this as the equation we looked at just the other day to see our fourth degree Taylor polynomial for cosine x. Now in our next problem, we're still going to work with cosine x again, but no longer is it centered at 0. It's going to be centered at pi over 4, and I'm asked for third degree. So we're going to go through the same process. We're going to take f of x equal to cosine x, and the derivatives are going to look the same. This time I need just through the third derivative, so I'll just quickly write these out. Here's my second derivative, negative cosine x, and my third derivative, which is sine x. Now, instead of evaluating it at 0, I'm going to be evaluating all of these at pi over 4. So cosine of pi over 4 is root 2 over 2. The first derivative at pi over 4 is going to be the negative sine of pi over 4, and the sine of pi over 2 is root 2 over 2. Then we take the second derivative at pi over 4. That's going to be the negative cosine of pi over 4, root 2 over 2. And then the third derivative at pi over 4 is also root 2 over 2. Again, we have all the building blocks ready to write a Taylor polynomial of third degree, so we're going to do p sub 3. All right, so here we go. The first thing we need is our value at pi over 4. So we grab that very first root 2 over 2. And just so we're clear, this is the one I just used. Next, I'm going to take the first derivative here. There's the first derivative, negative root 2 over 2. And I take that times x minus pi over 4. Now we're ready for the second derivative. So here's the second derivative. It looks like the same number, but that's the one I grabbed. Negative root 2 over 2. That gets divided by 2 factorial x minus pi over 4 squared. Now, that looks a little confusing, and I'm going to actually rewrite this another way once I get my eraser to work. So we're going to take this, and rather than dividing by 2 factorial, we can also multiply it. I'm having technical difficulties. Let's see if I can get this fixed without having to start my recording all over again. All right. And good news, we're in business. So we're going to multiply this by 1 over 2 factorial. Same thing as dividing by 2 factorial. X minus pi over 4 squared. And then our last one, the third derivative from here, we've got root 2 over 2. We have to divide this one by 3 factorial, so times 1 over 3 factorial x minus pi over 4 cubed. All right, so we've written our third degree Taylor polynomial, but often when you see these in the back of the book, for instance, it will get cleaned up a little bit. So we're going to do that right here. So root 2 over 2 minus root 2 over 2 x minus pi over 4. This one is going to clean up to root 2 over 4 x minus pi over 4 squared, and then 3 factorial 6 times 2 is 12, so root 2 over 12 times x minus pi over 4 cubed. There we go. We have our third degree Taylor polynomial. Something you might want to try doing is plugging this into your calculator and taking a look and seeing how when you graph this, it's going to match cosine x right at the point pi over 4 root 2 over 2. And you'll see that as you move farther from that point, it'll move farther away from the curve. All right, that's it for this lesson.